Alright, in this video I want to extend our idea of angles within a circle. We've talked about central angles and how the measure of the angle, let's say this is 60 degrees, relates to the value of the arc. I can think of this as a 60-degree arc within that circle. It tells me the relative size of the arc compared to the whole circle. In this video, I want to extend the idea of a central angle to what's called an inscribed angle, where we have an angle that goes from where the vertex of the angle is on the edge of the circle as well. So the 2 points on the circle over here, and the vertex is at the edge of the circle over here. So if we compare that quickly to the central angle that has the same arc, I hope it's pretty clear that the inscribed angle over here is going to be smaller. Right? So if this is 60 degrees, let's say, or maybe 80 degrees, just to give a different number to it, then this would be an 80-degree angle, but over here we're going to have an angle that's less. This angle is going to be less than 80 degrees. Because we're pulling the vertex farther away, and it's going to make the angle smaller. Like imagine stretching a rubber band. It's going to get smaller if you pull it farther away from where you're holding it on the other side. The question, though, is how much smaller? It turns out that an inscribed angle is always half the size of the subtended arc. So we call this the subtended arc, or we say the angle subtends this arc. So if this is, let's say, 70 degrees, this would have to be how much? The angle over here would have to be half that amount, so it would be 35. So this leads to some interesting sort of problems. In particular, let's say I have a quadrilateral, a four-sided figure with its vertices on a circle. And let's say we know that the measure here is 60 degrees and the measure here is 100 degrees. Is there any way to figure out the measure of these two angles? And the answer is yes. We can extend things to the arc lengths. The arc length here has to be how much? Well, let's think about what's the inscribed angle related to that red arc length. It's this angle. This is an inscribed angle that subtends that arc. And so the measure of the angle over here is not equal to the arc, but exactly half the size of the arc. So this arc length has to be 120. Likewise, 100 subtends this arc. It's not a totally different arc. It overlaps the first one, but it subtends this arc. This angle is 100 degrees, and so this has to be a 200-degree arc. So to think about x and y, what we need to realize is that this is the major arc between these 2 points. What about the minor arc? If this is 200 degrees, on the other side, we get an arc that's how big? You guessed it, 160. And in a similar way, you can probably guess, take a moment and share with a neighbor, what do you think this is going to be? The major arc related to this minor arc. Well, since this is 120, on the other side we get 240. So thinking about how the inscribed angle relates to arc length, This inscribed angle corresponds to the dotted red major arc, and so the measure of this angle has to be 120. And this minor arc corresponds to this inscribed angle, and so the value of y has to be 80 degrees. So in particular, something that's interesting, what we see is that opposite angles are going to be supplementary. They're going to add up to 180. If you have a quadrilateral that's inscribed in a circle, opposite angles in that quadrilateral are always going to add up to 180, because the corresponding inscribed angles give us a minor arc and a major arc related to the same pair of points, and so we get the whole circle. Divide that in half, we get 180, and there we have it. So I'd like you to take this information and work on a few problems, talk with a neighbor, and try to figure it out together. I hope you enjoyed the video.